Hi guys, welcome back to my mathematics tutorial. And in this tutorial, we want to look at finding the derivatives of trigonometric function using the first principle of derivative. And particularly, we'll be finding the derivative of 𝑐𝑠𝑐𝑥 or cosecant of x. So we know that cosecant of x is equal to 1 over sine of x, right? So now, wheresoever we see f of x, we're going to write 1 over sine of x. But we don't have f of x plus h. So we're replacing this x now with x plus h. So remember, the original function is 1 over sine of x. So anywhere we see x, we put x plus h. So we put it in the problem now. We have f prime of x equals to the limit of f of x plus h minus f of x all over h. H gets closer and closer to 0, or h is approaching 0. So anywhere I see f of x plus h, I'm going to write this expression. So the limit of 1 over sine of x plus h minus 1 over sine of x, all divided by h, as h approaching 0. So the numerator expression, we can simplify it. The limit of, so we find the LCD for this and this is just the same, it's just a multiplication of the two of them. So we say sine of x plus h. So sine of x plus h goes into this LCD. Sine of x plus h will cancel. You'll be left with sine of x. So it's sine of x times 1, which is sine of x. Minus sine of x goes into this one, it cancels. You're left with this one. So it's sine of x plus h times 1, which is sine of x plus h. Now divided by h, as h is approaching 0. So our next target here is to expand this numerator. Leave this denominator and just expand this numerator and simplify. So if we expand the numerator, you will have sine of x minus, now this one now is, let me put this whole thing in bracket, sine of x cos of h plus sine of h cos of x. So this is the expansion for sine of a sum. Let me use parentheses because I thought it was. All divided by sine of x plus h times 1 over h. We can reciprocate this and then we change this sign to multiplication. As h now is approaching 0, f prime of x is equal to the limit of sine of x minus, now this negative must affect everything, sine of x cos of h minus sine of h cos of x, all divided by, so I'm going to multiply this h by this expression. Says h sine of x plus h, as h now is approaching 0. So we further simplify. Now, remember that we can still bring in either of these properties. So we look in the numerator, we have sine of x, and here we have sine of x as well. And this last term and this middle term does not have a common factor, but the first and the second has a common factor. So we can group the first and the second. So we say f prime of x is equal to the limit. So we group the first two terms, sine of x minus sine of x cos of h. We have them grouped minus sine of h cos of x. So we can express the denominator now separately. So the first one we say h sine of x plus h. And the next one we say h sine of x plus h. So we write them separately as h approaches 0, f prime of x. So now the next thing we do is that we can factor out sine of x here because it is common. But we can also take the limit of each term, this term and this term. So we take the limit of this term. So we're going to factor out this sine of x, right? So sine of x comes outside. You're left with 1. 1 is here. Minus cos of h. So if you look there, 1 minus cos of h has to do with something that we are playing with right now. So it's h sine of x plus h as h approaches 0. Minus, we take the limit of this side as well. Sine of h cos of x over h sine of x plus h as h approaches 0. Now we almost done. We are just approaching our answer. So we have f prime of x is equals. Now in this term, since h it is the variable that is approaching this value, it means every other variable in this function, right, in this expression, makes that expression to be a constant. So sine of x is a constant. So we can bring sine of x behind the limit. Also, what is also a constant? Sine of x. In fact, this sine of x can cancel this sine of x. So we don't need to hurt ourselves. Likewise, okay, nothing can cancel from that. So we just left with sine of x plus h. But in this x plus h, one of them is a constant and one of them is not a constant. So we cannot say this whole expression is a constant to factor it out. So there's what we do. We can write this as 1 all over the limit of 1 minus cos of x, cos of h, divided by h. Then we say times 1 all over sine of x plus h. We have not changed anything. It still remains the same. Because if you multiply this by this h, you'll be left with h sine of x plus h. If you multiply this 1 by this numerator, it still gives you the same thing. Why did we do what we just were doing? We did it because we want to bring in this property so that this expression can go to 0. Because if we just leave this thing like this, h in this denominator will give us tough time to get rid of. Because if h is not getting rid of, or if we do not get rid of h, then it means that the denominator is going to take this whole problem to undefined. Just this denominator h will make this whole thing to be undefined. So our aim is to get rid of this h. That's why we brought in this theorem. The limit of this particular expression is equal to 0. So if this whole thing now is 0, it means 0 times 1 over sine of x plus 0, because we're replacing the h now. This whole thing, in fact, we just maintain this h. This whole thing will go to 0. We move to the next expression. In this expression, we have the limit of sine of h divided by h. Sine of h divided by h, we know that this whole thing gives us 1. So we want to maintain it. Then cos of x is a constant, right? Divided by sine of x, which is also a constant. times sine of x plus h, which is not a constant, as h approaches 0. So this expression right here, limit of this expression, it gives us 1 times cos of x all over sine of x plus, so we know that h now is 0. So if this expression is 0 now, so you have sine of x times sine of x. So this whole thing will just give us cos minus cos of x all over sine of x times sine of x. So this can be minus sine of, that's a cos of x all over sine of x times 1 all over sine of x. So what is cos over sine? Cos over sine is cot of x. And what is 1 over sine? 1 over sine is cosecant of x. Therefore, the derivative of cosecant of x is just equal to cosecant of x times, let me attach the negative first, cosecant of x times cotangent of x. Or you can say cotangent of x times cosecant of x. It's still the same. That's multiplication. So thanks ever so much for watching. See you next video. Oh, it's like after 5.